Okay, let's start. So, hello everyone. Thank you for having me here at Virtual Jack 24 and letting me talk about the Spock. So, what's a Spock? Well, a Spock is a Groovy-based testing and specification framework for Java and for Groovy applications that makes writing tests fun again. We can write beautiful and highly expressive tests because of its DSL and all the power that Groovy provides us. So we can write tests with less lines of code that are going to be very, very readable. Spock is totally compatible with JUnit, so you can use your standard tools, which means that you can use your IDEs such as IntelliJ, Eclipse, NetBeans, your build tools, Maven, Gradle, and your continuous integration servers, Jenkins, Bamboo, whatever you use. So during this talk, I'm going to show you a lot of nice features about Spock. So maybe at the end of the talk, you can try Spock in your current project. Okay, first, let me introduce myself. I'm Ivan Lopez at Ilomar on Twitter. I work as a Groovy and Grails developer. I'm a member of the Grails team at OCI. OCI is the home of the Grails team now. I'm also the coordinator of the Madrid Groovy user group, our local Groovy group in Madrid. We have meetups once a month. And I'm also the organizer of the GRITCH conference. GRITCH is a conference about Groovy in Madrid. This past April was our 5th edition, and next year we have our 6th. We haven't announced yet the dates, and you have in our webpage all the information. And I'm also a regular speaker in different conferences, Spring One, CodeMotion, GreatConf, Spring I/O. I like to talk about Groovy. So I could spend something like 20 minutes talking about why it's important to test our applications and explaining a lot of theory about unit testing and all that stuff. But I assume that you all test your applications, or at least if you don't test them, you know the benefits of testing the applications, right? And on the other side, we are developers and we love to see code. So instead of talking about a lot of theory, what I'm going to do now is just let's Spock. So this is basically my last slide. And what I'm going to do is show you something like a Spock in action. So here you can see I'm using IntelliJ, and I have created this project. It's a Gradle project. So the first thing you need to do, or the only thing you need to do if you want to try Spock, this lines doesn't exist yet, is just add Spock, add the dependency, right? I'm using the latest RC2 version. And with only this line, you can just start using Spock. With this version, Spock came with or has its own Groovy version. So this version is using Groovy 2.4.6. So if you want to use a different version, you can just add it here, because I want to use the latest Groovy version, right? And that's all that you need. So with this very simple setup, we can start writing our test. So as I said, this is a Gradle project, and it's the standard layout, source main Java. And here I have some Java code that I'm going to test using Spock. And here, source test Groovy, I have my tests, right? So let's start with a very basic one. So the first thing you need to do if you want to write a Spock test is create a class and extends from a specification, Spock lang specification. As I said, Spock, it's compatible with JUnit. And as you can see here, Spock use this run with, which is the runner, the JUnit runner. And Spock has its own runner, which is the name is Sputnik. The name comes from Spock and JUnit. And here, it's all the code that Spock needs to do to be able to run as a JUnit test. But you don't need to worry about it. So just extend from a specification, and you are ready to go. So let's write our first test. This is a very simple one. And the first thing you can see is that you can write the name of the test using plain English. You don't need to write these method names with camel case that sometimes are not readable. So just write plain English. And the other thing is that Spock forced us to write our test using this BDD form, given when then. So the first thing you can do when you start writing a new test is do something probably like this. You can write your labels, given when then, write a small description of what you get, what you want to do. So in the given block, you have your start, your setup. So I have a string. In the when, this is what I want to test. I want to test what will happen when I reverse the string. And in the then block, I have my assertions. So everything here in the then block are assets. So I don't need to write asset here. It's implicit. And as you can see, it's very simple in this case. So if you are used to use the unit, you probably can write this test in this given when then form, but you will end up with something like this, given when then in comments, because you don't have to, or you can't use this form with the unit, right? The nice thing about this, let's run this test. So it's green. So the nice thing about this given when then block form is that Spock forced us to write the test this way. So I can't do something like this. Then true. If I try to run this test now, it's going to fail. I mean, it doesn't compile because then it's not allowed here, right? So you need to write the tests in the right way, okay? So let's fix this. And this is as I said, the regular form given when then, but sometimes for these examples, this is very verbose. So we have a shortcut, which is expect with this keyword or with this label. What I'm saying here is I expect that when I execute this, it will be this thing, hello world reversed, right? Okay, let's move to the next example. Here, let's talk about power assets. So it's important to, when a test fails, it's important to know or to see why the test has failed, right? So this is a very simple example, 2 times 3 and 5 times 4, which 6 is not 20. So the first thing I need to do is just comment this annotation at ignore, the same as the unit. With this annotation on a class or on a method test, this test will be ignored. But the Spock has another really useful annotation, which is called ignore rest. The use case for this is that imagine that you have a test class with, I don't know, 25 tests, and you are focused only on one of them. You can put this annotation on that test and just fix it and run it. And Spock, we only execute the test that has this annotation, right? So let's run this first example and let's see what happens. Okay, it has failed. And you can see this nice output. You can see the value of every variable here. So 2 times 3 is 6, 5 times 4, it's 20, which is false, right? This is what I expect, 20, but this is what I get, 6. This is a pretty simple example, but I have another one that you will understand and we see better. So I have this data. This is a Groovy syntax for a map. So key, name, value, Ivan, key age, value, 36. And this is another key which has a list of elements. So what I want to check is that the name of the first child could be Adriana, but it's not because this is a list. So it's Judith. This test is going to fail, right? Let's run it. Okay, and as you can see, we have the values of every variable involved in the assertion. So in data, we have everything. Then we just extract the child, which is just this list. Then we get the name of the child, Judith and Adriana. The first one, Judith, which is not Adriana, right? So you can see here, even this thing, they are 40% similar. Although I should say they are not that they are more similar because They are both my daughters and they are siblings. But anyway, you can see here that you have all the information to know why this test has failed. You don't need to put a breakpoint and debug the test or write a lot of print lines to actually see what happened here. Okay, let's move to the next one. So as I said, I want to show you how you can use Groovy to test your Java code. So here I have this data helper, and this is Java code. You can see here the section Java, and you know that this code is Java because it has semicolons and it's really a bit verbose. But anyway, here I'm just returning a Fibonacci sequence with these elements 1, 1, 2, 3, 5, 8, and 13. So I'm returning a list of integers. And I save here and numbers. And what I want to test is that when I add a new number, and this left shift operator is overloaded in Groovy for lists. So it's the same as if I execute numbers.add. I want to check that this list contains this value that I have just added. And run it, and it's green, right? So we are testing here our Java code. Remember, this is Java, and we are testing here from Groovy. Another example, this is more interesting because here I have this list of users. So user is just a POJO with name, last name, constructors, getter and setters. So nothing new here. And I am creating a list with 4 users, Sheldon, Leonard, Raj, and Howard. So this is a pretty common pattern when we do test our application, because we, for example, go to database, get some data, and want to do some checks on the list of objects that we have returned from the database. So let me put this here. I'm going to do this, and I'm going to do this. So these are some things that we can check about this list that I'm going to return. So the size is 4 because I have 4 users. The name of the users are Sheldon, Leonard, Raj, and Howard in this order, right? This order here. If I sort the names alphabetically, now the names are Howard, Leonard, Raj, and Sheldon. And we can do more things. So for example, we can get the last name of the users and create a new list with collect with the size of every last name. So now this is 6, 10, 12, and 8 because Cooper has 6 letters, Hoofstopper has 10, Cruthopoli has 12, and Wolowit 8. And in the last line here, what I'm doing is just getting the user with the smallest name, right? And I want to take here a moment because this users.name, if you are not very familiar with Groovy, this is probably something that you are thinking how this is working, because remember, in users, I'm saving here this list of users, and I'm just executing users.name. So, print users.name. So here users. I'm getting the name of every user on the list. We can write this here with this spread operator, which is pretty much the same. It will execute this method or this call on every object of the list. We can also do users.collect to create a new list. So I can say here it.name. And as you can see, IntelliJ knows that this is a users list. So I have auto completion for name, last name. Okay. I can also do something like this in probably a more Java way, which is get name, right? And if I want to go to more a Java approach, I can do something like this. I'm going to use the stream API. So a stream. So the first thing I need to do is just map. And here I need to pass a lambda. In Groovy, we have closures, which are pretty much the same as lambda. So instead of passing a lambda, I'm going to pass a closure. Okay. So I can say, again, it.name. And then I need to collect collectors to list, right? And in this final one, this should be probably the most Java common code, which is get, sorry, you get name. So I'm going to run this test again. And as you can see, it's the same output in every step. So let me delete all these intermediate steps because I want you to compare, to show the difference between these two lines of code. They are the same, right? And I can do here this here. So if I run the test, it should pass again. Okay, but once you know how to read this, I think it's way more readable than this line. I'm not saying that you cannot read this line because it's pretty simple. I stream the list, I extract every name, and then I create a new list with the names. But remember, your test needs also to be readable. So why you want to do something like this if you can write just this line here? Okay. And for the last example here, I have another method, which is I'm returning a hash map, which is with these three keys: name, last name, and age. And what I'm doing here, let me do this again. We can do some checks. So I want to remove the name key. So now the map size will be 2. The key set won't contain now the name. And here you can see 3 different ways to get a key from the map. This one is the Java way to do this. And this first one, it's the more groovier way to get the key. So map.key, and we can run this test, and it should be green. Okay, let's move to the next one. 5, 4. So sometimes you need to check what happens when your code throws an exception. So I think that the test is it's readable. I try to convert foo to a long, and foo is not a valid long value. So this test will throw number format exception, and this is what I want to check, right? I'm going to run it. It passed, and I can do even more things. So what I'm going to do now is just save here the exception, and I can do asserts on my exception. So as you can see, IntelliJ again knows that this is a number format exception, and here I can check anything I want. So for example, I can check the message. So this should be something like for input a string foo. Let's run it again. Oh, it has failed. Right, the colon. Okay, now it's green. So imagine that instead of launching or catching number format exception, you have your own exception hierarchy. And here you catch your own exception, and here you can test whatever you want, your message, your error code, some custom fields, whatever you want, right? So let me cheat a little bit to copy here. Should not throw an exception. So if now instead of checking that an exception has been thrown, I also can check that this number format exception has not been thrown, right? Because now the number 1, 2, 3, it's a valid long number. Okay, and the last thing I want to show you here with this example is what happens if I catch another exception. So for example, I'm going to catch null pointer exception, and this test is going to fail because the expected exception type was null pointer exception, but the code actually throws number format exception, right? So with these methods, you can check pretty much whatever you want related with exceptions. Move to the next one. So data-driven tests. This is one of the killer features of Spock. I think that you can do something like this one in JUnit using parameterized test. So the thing here is that imagine that you have one piece of code that you want to test in this example, it's pretty simple. I want to check that the number it's an even number. And you want to check this code with a lot of different inputs, right? So instead of copying and pasting this test a lot of times, you can do something like this. We introduce this new label, which is where. And here with where, we can define variables that are going to be used here on the test. So this test is going to execute it 5 times. And in every iteration, we have one of these values. Just put in this left shift and a list of values, okay? So another iteration about this one is that here we are using just one variable, but we can define whatever we want. So I want to check that the minimum of X and Y is resolved. And here I'm defining just 3 variables. But here, the thing here is that you need to read these variables in column mode. So the minimum between 1 and 2 is 1. The minimum between -1 and -2, it's -2. So it's nice, but we can do it even better, right? So here we have this table format. And here it's this code, it's the same and as in this example, but here we are writing this table, and now we can read the test in row mode, right? The minimum between 1 and 2 is 1. So for example, let's see what happens if one iteration or one value fails. I'm going to run this. Oh, and we can see here that the test has failed. And here we can see the values. This is a pretty simple example. So you will see here that -2, -1, okay, I know how to fix this. But when you have a more complicated values or example or actual real code, this won't be that simple to find. Imagine here you have a very big table with, I don't know, 10 rows, right? So we can do it even better. So for the next example, it's the same, but I have put here this unroll annotation. So what the Spock is going to do is just create, let's make this fail again, create a new output on the test report for every row in the word table, right? So now we can see here we have 3 different outputs, and we know that the second one, which is the index 1, has failed. This is good. This is an improvement over the previous example, but we can do it even better, because here what we can also do is just replace in the name of the test the variables X, Y, and result that we are using here. So now, if I run this one, we can see that the minimum between -1 and -2, it's -20, which is not. So this test has failed, right? And for the last example here, I want to show you, well, here I'm using a list, but with this left shift operator in the word block, you can use anything that it's iterable, right? So I have this example. Let's start in the word block. I have these users. This is a CSV file with username and last name, right? So what I'm going to do, or what I'm doing actually here, is I'm reading this file. I read the lines, and I'm creating a list splitting by comma. So basically, I'm parsing this CSV file. And please don't do that. Don't do this code on production. This is a very ugly way to parse a CSV file. It's fine for a demo and for test code, but for production code, please use a library to parse CSV, right? So with every part of name, last name, I'm creating a new list with the name and the last name. And then with these values, we can go here to the given part. And here I'm using a Groovy trick. This is called coercion. I'm coercing this map. Remember, name key. This is the key and value, key and value. And I'm coercing this map to a user. And this is working because user has this name and last name. And again, this is Java code. So the first thing I want to check is that this user instance is an instance of the user class. And also, I want to check that the name and the last name are what I expect. And I think that you don't believe me because this is not a trivial or not that simple example. So what I'm going to do here, I'm going to add a new name, my name. And here, what I'm going to do is just put this and role annotation and write this. Name equals the name. And again, IntelliJ knows about this, and I have auto completion here on the name. And last name equals the last name. Okay, so let's run this test. And as you can see here, I have the 5 user names, and the test will pass or has been passed, right? Okay, let's move to the next one, E6. Life cycle. Spock has a life cycle that you can use to hook into the execution to do something that you want, right? I have here this just 2 tests that will only print test and test2. And you can define these methods: setup spec, setup, cleanup, and cleanup spec. You don't need to define the tests in this order. You don't need to declare all of them. You can use whatever you want. So the thing is that setup spec will be executed at the very beginning of this specification, this code, this test. Then setup will be executed before each test. Then we have the test executed, then cleanup, then setup, test, cleanup, setup, test, cleanup, and so on and so forth. And cleanup spec will be executed at the very end. So if I run this test, you can see here, setup spec is executed only once at the very beginning, cleanup spec only once at the very end, and then setup, the first test, which is this one, cleanup, and then setup, test2, cleanup. Okay, so you can use this, for example, to open a, I don't know, a connection to the database, to create some objects, and to do all this initialization setup that you sometimes need to do when you are testing some code. Okay, so here, this is another example. Imagine that you have this test, and you want to share this user with these 2 tests. So the first thing that you can think is, okay, let's define the user here, and it will be the same for both tests, right? Let's see what happens if I run the tests. So as you can see, they are not the same user. So this code, it's just the same as this one, dev, setup, user, sorry. Okay, this is exactly the same code, that this is worst. So there is, if you remember the previous example about the life cycle, maybe you can think, okay, instead of using setup that will be executed at the very beginning of every test, let's execute or let's define setup expect, which only will be executed once at the very beginning. So let's see what happens if I execute it. Okay, so the code doesn't compile. Here you have an error, only share and static fields may be accessed from here. And this is actually the answer to our code. So what we can do is use this at share annotation, right? This annotation, let's run it. We are achieving 2 things. The first one is that we are achieving, we are sharing this user in all of the tests. And the second one is that it's something like documenting your test, right? The next people that we will try to modify this test will see this share annotation, and we think, okay, this user is shared in all of the tests, so I need to deal with it. And this shared is also useful because here I'm creating just a user, which is it's cheap to create a new user, but sometimes you can open here a connection to an external service, a database, and you don't want to open and open and open again the same connection or create these expensive objects, right? Okay, let's move to the next one. Mocking. This is important, right? Spock came with its own mocking and stubbing framework. You don't need to use Mockito or PowerMock or anything else. And mocking, it's important to understand the concept, because when you are testing some code, sometimes you have to deal with some collaborators. And when you need to test that code, you don't want to deal with these collaborators because you are going to unit test them in another place, right? With mocking, what we are going to do is just replace this collaborator with a mock object, which is an empty object in which we are going to test behavior. So let's see the example here. This is what I want to test. I'm going to create a new user. So I'm going to test what happens when I create a user in this user service. Okay. So this user service, this is again Java code. This is an standalone example, but you can think about it just, for example, using Spring Framework. I have this collaborator notification service. I use constructor injection. So what I'm doing here is basically I create a user, store the user on database, do all my business logic, and at the end, I want to notify the user, for example, sending an email, that the account has been created, right? So when I unit test this code, I don't want to deal with the notification service. I will test notification service in another place, but now I don't want to be bothered by notification service. So what I want to do is just create a mock. So I'm going to mock notification service, which is it's just an interface. I don't have an implementation for this service. And here I create my user service with this mock, right? And when I execute this code, what I want to check is that this send notification has been executed only once in this notification service. Let's run it. It's green, right? And here, the underscore means I don't care about this parameter, because remember, this here I'm notifying to a user, and with this message, you should create it. Okay. So if you don't care about any parameters, you can write this. And it will be, so Spock we won't check any of those parameters. And if you don't care about this method, you can put here another underscore. So for example, let's run it. Excellent. And if you even don't care about the mock, you can put here another underscore. And here, you know how it's going to end. If you don't care about the number of times that this mock is executed, you can put here another underscore, right? So this is really ugly, and this is really bad. If some of your coworkers write this code, you are allowed to punch him or her, or I don't know, cut a finger or something like that, because this is really, really ugly code. You shouldn't do this, right? The only use case to do this is here. Imagine that you want to check that after this method has been executed on the mock service, no more mocks are executed. So you can put here a 0, and let's run it. It's green. So if I just execute, so for example, if I execute this twice, this test now is going to fail, right? Okay. Well, it has failed because I put here a 1, but it's the same. So this is pretty common. So there is a shortcut, which is this one, 0 times underscore. And this is really useful if you want to make sure that only this method has been executed on the mock object. Let's fix this. So here I said that I don't care about this parameter, but you can do some behaviors, or you can check something on those parameters. The thing is that here, this user, it's a local variable that I'm creating here inside this method, so I cannot access to this user from outside of this method, right? So with a Spock, you can put here a closure and check whatever Boolean condition you want about this variable. So here it's a user, so I can check that the name is Ivan, right? And sometimes you need to mock an implementation. So let's go back here. Remember these 2 lines. If you want to mock an implementation, you need to add this cglib dependency on your class path, because if not, Spock won't be able to mock an implementation. You should use interfaces, but sometimes you don't have another choice, and you need to mock an implementation. So email service now, it's just simple implementation. It will just print these values. So with this mock, what I'm going to check is that when I call this method on the mock, it's executed, right? And the last example is about the order of the check. So imagine that you send 3 messages and you want to make sure that the messages are sent or processed in this right order. So message 1, 2, and 3, right? So you need to put 3 then blocks. Let's run it. It's green. But now if I change the order of the messages, 2, 1, 3, and run the test again, it's going to fail because Spock will force the order in every then block. But if you remove these then blocks and put all of them in the same then block, the test is going to pass again because Spock won't check the order in a then block. So you need to put more than then block if you want to check the order between them. Okay, let's move to the next one, stubbing. So with mocks, we replace our collaborators with an empty implementation, right? With a stubbing or with a stub, what we are doing is just modifying this object, this collaborator, and make it to return a predefined value, a value that we want. So I have here this user repository. It's, again, an interface. I don't have the implementation. And here I have 2 methods, find by ID, which receive an ID and return a user, and find all by last name. We receive a last name and return a list of users. So I can stop this repository. So using this keyword, this method name, stop user repository, here I can define the method that I want to stop. Here I'm saying I don't care about the parameter, and you need to return something that will have the same signature. So find by ID is returning a user. So here I need to return a user. So when I execute this find by ID method on this stub repository, Spock will return this John Doe user, right? We can define also different values for every call. So here I'm using the right shift operator. And here with this one, I don't know the name, sorry. Inside of this list, you can define more than one user. So for the first call, Spock will return the first one. For the second call, it will return the second one. And here I'm just executing the method 3 times, but I only have 2 users here. So Spock is going to return the last value, right? And again, here I don't care about the parameter. I'm just calling with 1. And in user 1, I have John, because John is the first element of this list. And for the user 2 and user 3, I have Jane, right? Because it's the second one and it's the last one for this in this call. We can also return values depending on the input. So if I execute this find by ID with 11, here it will match with this one and it will return John. It doesn't matter if I have defined first 20 and then 11 and call it in the other way, in the other order. So 11, it's here, it's John. So user 1, John, and user 2, it's Jane. We can also stop our repository to, for example, throw an exception. So we just need to write inside this closure the exception we want, throw new runtime exception. And here, as I already show, you can check that this exception has been thrown, and this is the message. So for example, if I change the message and run the test, okay, the test failed because the message is not the same. And for this last example, I want to show you that you can stop more than one method, right? In user repository has 2 methods. And in all those examples, I was only stubbing find by ID, but you can define all the methods that you want. Okay, so let's run for the next example. I think that I won't be able to finish all the examples, but don't worry because the code will be available on GitHub, and these last examples are pretty simple, right? So here, this is pretty common. I want to check something. So what I want to check is what would happen in the size of this list when I add a new number. This is how you define a list in Groovy with square brackets. And here you can do something like this. So, and the size is numbers.size, right? And after adding this new value to the list, I want to check that now numbers.size, it's the value that we previously saved plus 1, right? This test should be true, should be passed. Right. And we are doing this because we are developers and we think in that way. So we know that here we need to check the old value. So we are going to just save the value here and use it here. But this is not how a regular, a normal person would think, because what we are thinking in our brains is just actually, I want to check that the number size now is the old value of the number size plus 1, right? This is the same. S is green. And what Spock is doing with this all, it's just what I did. He says, Spock says here, okay, numbers of site. I'm going to move this code to the given block. I'm going to execute it. I'm going to save the value. And then I'm going to use it here. So this all, it's useful. You can use it not all the time, but sometimes. And I think this, at least one, that's one. So this thing that I'm going to show you now was introduced in Spock 1.1. So what would happen, I'm creating a user here, and I'm checking that the name and the last name are not the same. So if I execute this test, what is going to happen is that it's going to fail because the name is Ivan. And then I fix this test, I run it again, and it's going to fail again because the last name is wrong. So yeah, it's Lopez. So this is the default behavior of Spock. It will just stop after the first failure. But if you want to make sure that all your block is checked, you can use verify all. Inside of this closure, Spock will verify all of your assertions. So here, you can see that, let me put this here, user.name, it's false. And then another condition, user last name, it's false. So all of the assertions has been checked. This is really useful because sometimes you don't want to fix the test one and over and over and over again because you have a lot of assertions here, sorry. And every time you fix one, you have a new failure, right? Okay, let me show you. I think the last thing I'm going to show you, I'm skipping 2 examples, but they'll be available and they are pretty simple. And the last thing I want to show you is this auto dependency that I had here. This is this Spock reports. So what I'm going to do now is just execute all my tests using Gradle, right? And I don't care if some tests fail, some tests pass. I only want to execute the full test battery. Okay, you can see here that all the output. And what I want to show you is this one. This is the output of the test. So here in test results, we have these XMLs, and these are the XMLs. These are JUnit compatible. So you can put this on your Jenkins, for example, to see the output and have a nice report. And here we have in this reports folder, we have this index. Let me open with Firefox. So this is just Gradle standard test report, right? Some tests has failed, we have ignored tests, some failing, packages, some stats. But with these Spock reports on the class path, we have here a new folder, which is called Spock reports. Let me open this index, right? So this is basically the same information as here. Some tests has failed, some tests has been skipped. But let me show you this one, basic here and basic here. Let's go back to this example. E1. And as you can see, I write here this small explanation of what I'm doing. I've only did this in this example, but it's a good practice to write just a small line explaining what you want to achieve with this test. So with Gradle, you can see that's the name of the test, but with Spock reports, you can see that this information has been extracted and it's available on the report, right? And the same would happen if we open this data-driven. Here we can see just the test, but with the Spock reports, we have all our values, all our tables, and everything that we have defined. And the nice thing about these Spock reports is that you can customize these styles, this CSS, and this page. So you can put your own logo, your company colors, whatever you want, and you can create these nice reports for some people, for example, for some business people, because they will probably can read something like this, right? If you write a spec and where, they can understand this. They don't need to be as technical as you, and they will be able to understand that. And I think that's all. Let me finish my slides. So these are just resources. The first one is the Spock Framework webpage. Here is the GitHub repository. And the last one is the documentation. The documentation is really good. They explain everything, Spock, mock, and all of that. And I think that's all. If you have some questions now, I think we have some time. So let me stop share my screen. So, Simon,
awesome. Are you there? I am here. Thank you very, very much, Ivan. And it's always good to see a kind of a very fluid live coding demo. So that was awesome.
Thank you very much.
So if anyone has any questions, feel free to drop them straight into IRC. There's one question actually from Corsibu saying, out of curiosity, and this is actually a while back, maybe 20 minutes ago, no, about 15 minutes ago, why are you using constructor injection and not Spring's auto-wired annotation?
Yeah. Because here, this is, as I said, it's a plain Java test, so plain Java code. I'm not using Spring here, but you can use AutoWire, although that is considered a bad practice. You shouldn't use define your private collaborator and AutoWire it. You should use constructor injection, because in that way you can replace that object, that collaborator, with a mock, as I did. So you should do constructor injection.
Okay. Right. So a couple of questions now. Alasdale saying, is it possible to reuse the same parameters but for different use cases? Is it different test cases?
It's possible to use. I think that you can. I mean, you need to copy or put the word block in every test case. But I think you can, instead of just returning or writing, hard coding a list with all your values, you can call a method which will return the values that you want. You can write a private method on the same test class if you want, and just call that method from different tests. So yes, you can do it.
Okay. Another question from Matty in IRC. Hi, I want to ask about Spring applications with contexts running. He says that there are some problems with mocking beans. Could you tell us how to deal with Spock mocks and Spring beans?
Yeah, there's not a problem. I develop Grails applications, and Grails uses Spring under the hood, and I also have developed Spring Boot applications, and I always test my code with Spock. So I don't have any problem. You can just mock whatever bean you want. And if you are just executing integration tests with the context running, you can also do it. Although it's dangerous because you are mocking a bean that should be singleton, and you are just replacing the bean on the context. So you will have some unexpected behavior in other contexts, in other tests, sorry. But you can do it. There is another dependency that you can add to your project, which is called, I think, Spring Spock or Spock Spring. I never remember the name, and you can use it to integrate in a more fine way with Spring. But yeah, you can use Spock to test your Spring framework applications.
Okay. Are there any sample projects or anything like that? I mean, presumably there'll be something around.
Yeah, I think there are some samples there. Yes.
Okay, awesome. A follow-up actually from Alastair on IRC asking, is it then possible to return a table of parameters from a method? Presumably this is just returning a hash table or a hash map.
If you want to return this table that you write in the word block, I think you can't.
Okay.
I'm not sure, but I think you can. And yeah, returning a hash table or whatever, it's valid. But the table that you can write there, I think you need to write there in the word block.
Okay. We have time for just one more question from Lubos M. Can Spock mock? It's awkward that it rhymes. Can Spock mock static methods defined in Java?
Yes, Spock. I think it's possible. I'm not sure. If you can't use Spock to mock your static methods, you can always use Groovy, right? Because you can override the meta class of that class that you want to mock, and just replace the implementation of that static method. So I'm not sure now about the Spock, but from Groovy point of view, you can just replace modifying the meta class static method. Yes.
Okay, so that's all the questions that we have, and we're bang on time, 5 to 1 here in the UK. So Ivan, I'll just say a big thank you very much for joining us on VJUG 24. It's a pleasure having you as a first-time speaker. So thanks very much for your session. Did you enjoy it?
Yeah, it was funny, and yeah, thank you very much for having me here, and let me talk a little bit about Spock and Groovy. Thank you very much.
It's our pleasure. Awesome. So the next session coming up, let me share this screen.